Hello, friends. Welcome back. Let us see the problem of the day from the Leetcode. Problem number is 1171. It is remove zero sum consecutive nodes from linked list. Let us see the problem. It is given a head linked list. We repeatedly delete consecutive sequences of nodes that sum to zero until there are no such sequences. We have to delete the nodes whose consecutive sum equal to zero. And after doing so, we have to return the head of the final linked list. Let us see example 1. Here the head is pointing at 1. Here we can see that there are two possible sequences so that the sum will be 0. Here 1, 2, 3. The sum is 0 and another one is minus 3, 3. The sum is 0. We can delete 1, 2, minus 3 and we can return only 3, 1. Or we can return 3, 3 or and we can return 1, 2, 1. So let's see example 2. The given head is 1, 2, 3 minus 3, 4. The head is representing at 1. Here we can also see that here 3n minus 3 uh, sum is equal to 0 and we can remove and we can return the 1, 2, 4. And here the example 3, here the same 3n minus 3, we can remove 3 and minus 3. In the remaining 1, 2 minus 2, again we can remove this 2 and this 2 as the sum will become 0 and we can return only 1. Here we are using a two pointer approach to solve this problem. The basic idea is here, let us see the coding part. Uh, in the constraint, let us see once see the constraints. In the given constraints are the given linked list can have at most 1000 nodes and the value in that particular node can be in between the minus 1000 and the 1000. Let us see the coding part. Here the main idea is we are take before we are taking a dummy node to keep track of the head. Here we are creating new dummy node, that is list node dummy equal to new list node 0. Here new list node 0 will create new node and the pointer will be stored in the dummy. We are storing the dummy next to the head so that we can track the while returning at the end of the code to keep track of the head of the linked list. We are using dummy here. We are giving we are another thing is that we are taking current to traverse over the linked list. We are giving that dummy to the current and we will traverse until the current will become null. Means while current is not null, it will the code will while loop will runs, and if the current will become null, the the it will come out of the while loop and we will return the dummy next. As we have kept the dummy to keep track of the actual root of the node to return. So let us see here, the starting sum will become 0 and we will traverse from the next of current, so that we took the next node as current next, and we will traverse until the current next node will become null. Here we will every time we are adding the next node value to the sum, so that if we get at any time if we get sum as 0, we can remove that set of nodes for which we are getting the sum equal to 0. And here condition is if the sum is 0, we will execute this code, or else we will keep on traversing the linked list. Here if the sum is 0, what should we have to do that, current next equal to next node null, and we will continue the linked list traversing. And at last, for a particular current, if we didn't get any node that we have completed one traversal for a particular current, and we will do for the same for the next current next node, and the complexity is n square. Let us see the dry run of example 1. Here before we are creating a dummy node that is 0. Here head will become 0, 1, 2, minus 3, 3, 1, and the current will be dummy. Dummy means here, like here something will be there. For 0 it is pointing towards 0 and the sum is 0. List node, next node will become 1. Here our next node is 1 and the dummy node is here 0. uh, we will traverse by using the next node until it will become null. Here the next node is 1, so that we will add the next node value to the sum as sum equal to 1. As it is not equal to 0, we will keep on traversing. Next will become 2 and the sum is 3. 1 plus 2 3, and as it is not equal to 0, we will keep on traversing. The sum now will become 3 minus 3, so 0. Then we have to actually remove this set of values. For that, before we have current is here, and now the next node is at this position, it's pointed towards the minus 3. As we have to delete this 1 2 and minus 3, we have to uh, keep this pointing node to the current node. As current node next will become this is this pointing this address will, how we will get this address, by using the next node, next node, next node, next will have the address of this 3, so that we can remove 1 2 and minus 3. As we are not removing permanently from the memory, we will have that memory will be used for the removed nodes from the linked list, but they are not actually removed from the memory. So now the current will become, current is here. These 1 2 minus 3 are deleted, and now the next node will come to here. Here again, again we will traverse. Here we will add this value 3. Now the sum equal to 3. As it is not equal to 0, we will keep on traversing. Now the sum will become 3 plus 1 4. As it is not equal to 0, we will keep on traversing, and next we will get null. So we will come out of this while loop, and current will be updated to current next. As here 1 2 minus 3 are deleted, the current will shift to this 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 okay, sorry, this 3. uh, Now the next node will become 1. As the sum is not equal to 0, we'll keep on traversing, and the next will become null. Again current will uh, go one step ahead. Therefore current will become now 1. As the next node is 0, null, next node is null, so that it will come out of this while loop. Again current will become current next, that means after 1 there is no nodes, so that current will become null. So that we will come out of the outer while loop. As we have deleted 1 2 minus 3, and the current means dummy is pointing, dummy next node is now this 3. As we have deleted 1 2 minus 3, so that now we will have dummy node 3 and 1. As we have to, we are not we are not, if we return the dummy, as we have created for our own sake of solving the problem, so that we have to return the dummy next. As we you can see here, we have written the dummy next. Yeah, it's fine guys. Yeah, it's working fine guys. Thank you. I hope you understand the logic and the code, and I hope you understand the try run of the code. As you can see, the constraints are pretty less. Actually, while using linked list, we will actually have the less constraints, as it easy to solve questions from the linked list. Thank you.